The variability of Mediterranean forest types can be characterized by weather, climatic, edaphic, geomorphologic, heuristic, biogeographic, or historical, as well as their instability and vulnerability. Consequences of the former, caused by genetic and ecological variables as well as human activity, can be used to describe them. The mean annual temperature in the Mediterranean basin range from 5 to 8 degrees Celsius, and the mean annual precipitation range from 300 mm to more than 2,500 mm, both of which exhibit significant seasonal and yearly variations. As a result, drought occur frequently and can last anywhere from a few weeks to over 6 months. Fire condition in Mediterranean region. Regarding both the quantity of fires and the burn area, this appears to be a different trend. France and Greece have the fewest fire and the smallest annual fluctuations, while Portugal and Spain have the most fires and the highest values. For the Portugal, the burn area per fire was aggregated into 4 classes: 1, 1 to 25, 25 to 100, 100 to 500, and more than 500 hectares. In contrast, fires that have burned more than 500 hectares have the fewest event, which is 0.5%, but the highest percentage of burned land, which is 50% than other fires.
Effect of forest fire. Number 1. Depletion of forest area. Almost yearly, forest fires are seen in a variety of forest regions, which consistently reduce the quality of specific forest features like soil, fertility, biodiversity, and ecosystem. Number 2 is a negative impact on the environment. Smaller tree or plant under forest floor are frequently destroyed by wildfire, but larger trees may survive if the fire stay out of the canopy. The habitat for wildlife suffer greatly because of the extensive land destruction. Number 3 is a threat of human life. Buildings and homes along the path of the wildfire are burned, exposing toxic substances that endanger the public's health for first responders and during the clean-up process. Lastly is the impact to the economy. The fire altered the landscape, which increased the frequency and severity of floods that followed the fire and had additional negative economic effects. In addition, costly repair to damage infrastructure were required as a result of subsequent flooding and heavy rains.
Okay, now I will explain about existing monitoring effect. Existing monitoring effect that has been used in this case study is remote sensing system. Remote sensing system is a technology for acquiring visual data or other about a place from the air or space. Remote sensing includes familiar techniques such as aerial photo analysis, as well as novel technologies such as synthetic aperture radar interferometry (INSA). In contrast to inside or on-site observation, it is also a type of geospatial technology that collects electromagnetic radiation that is emitted and reflected from the Earth's terrestrial, atmospheric, and aquatic ecosystem to detect and monitor an area's physical characteristics and retrieve information about an object or phenomenon without coming in direct contact with it. This technique is also most cost-efficient and time-saving. Aerial photographs that are sensitive to infrared light and live plants reflect infrared wavelengths, which may be used to define extent of burn area and health of the forest. This procedure can aid in producing map of forest cover and estimation how much of forest that has been burned. Infrared radars are uh, highly precise information on vertical ground motion and active fire from the satellite photo. Satellite images are used to make these maps. The map of the forest cover shows open forest, water bodies, scrubs, non-forest moderately thick forest, and extremely dense forest. Okay, this is how satellite remote sensing is working. And this is a waveline that emitted from surface to the satellite. And this is the image that can be retrieved from the INSA satellite. That's all from me. I will pass it to the next person.
Assalamualaikum and a very good morning everyone. I am Nura Azira. So for today I'm going to explain about my part. So I'm going to explain for you, which is to evaluate the air pollution monitoring effort based on our case study. So I divide it by the two things. The first one is methods and facilities, and the second one is quality data. Okay, for the methods and facilities, I have listed two things. The first one is normalized difference vegetation index, or we call it NDVI, and the second one is remote sensing data. For the quality data, I also listed the same thing as the methods and facilities, which is remote sensing data. So let me explain for you what is NDVI. So for this study, NDVI is called the Normalized Difference Vegetation Index. It was used to calculate on the basis of the normalized difference between NIR and RED bands. So it was calculated both for pre and post fire periods as the mean value of NDVI before and after the fire event. So, the dates of satellite image acquisition were deliberately chosen to be a few days prior to the fire event and afterward annually on approximately the same dates to eliminate the possible variations originating from the different vegetation phenological stages. It means that the mean of the NDVI was obtained with the pixels located inside the selected burn areas, and the temporary vegetation variation was analyzed with the difference between the NDVI pre and post fire. So for the study, the four burn areas were extracted using the fire perimeter provided by the Portuguese Forest Fire Service. Okay, for the second one is remote sensing data. So the remote sensing data, I will explain for the both part, which is methods and facilities, and also the quality data. Remote sensing data is the most frequently uh, method that used to get the image from satellite, which we call it Landsat 8. So it is the most frequently used for image classification, vegetation indices, and spectrometer analysis. For the image classification, it enables the transformation of remotely sensed data into land cover or use classes using either supervised or unsupervised techniques. So the image from this satellite data were selected considering the similar acquisition date to minimize cloud cover and phenological stage effects. For fires were considered. So the image of 2013 on 6th of July 2013 covering fire 1, fire 2 and fire 4. It also corresponds to the pre-fire image and the other images to the post-fire 1, 2 and 3 after the fire. As to Fire 3, which occurred at the beginning of June of 2013, all images are post-fire. Thus, the time series enables the temporal vegetation analysis for a time frame of 3 years after the fire event. The satellite image were geometrically adjusted image to image, considering that of 2013 as a reference to ensure a minimum geometric pixel deviation. Thus, it is stated that we have in the study used NDVI and also the remote sensing data. Next, I'm going to explain about our improvement of air pollution monitoring plan based on the case study. Okay, so there are three. improvement that our team would like to share with you. The first one is small sensor, the second one is routine monitoring, and the third one is indoor air cleaner or filtration system. So let me explain for you for each type of this improvement method. So the first one is small sensor. We agree that the small sensor is an indicative method that can be used to improve the air pollution monitoring plan from this case study because it is low cost and user friendly. So this method is an alternative method that is able to indicate or mimic the concentration variation as it is measured by the reference or equivalent method. So within this small sensor, it is an emerging technology, a low power and small dimension device that detects pollutant concentration that can be used to measure particulates and various gases, and it only costs less than $2,000. So we agree that in order to improve the air pollution monitoring plan from the case study, we can use the small sensor and install it in every part of the field or the case study, the selection study field, so that we can get a lot of data, we can get more of data without having trouble to specify the data and others. So the second one is routine monitoring. For the routine monitoring, it is a conducting routine that can be used by the people that who are really interested to do a research about this particular matter that causes by the peatland fire. So we can form a group of 3 or 5 people to do routine monitoring by collect the data manually, and of course it is tired, but we can satisfy ourselves with the data as it less error and we can detect a lot of pollutants, and we can share with each other to get the best data ever. And the last one is indoor air cleaner or filtration system. It can be used to improve the method in the study because it is an combined technology and is portable and in-depth filter, because the people or the residents who are affected by the peatland fire in the resident area can use or install the air cleaner or filtration operation in their house to reduce the indoor concentration of particulate matter. The residents can use portable air cleaner with sufficient clean air delivery rate (CADR) based on the room size and in-duct filter with sufficiently high minimum efficiency reporting value. Under proper forced air system operation, so they can consider the air cleaners to help reduce the amount of particulate matter that are going in the atmosphere and keep the air clean. So I hope this method can improve the air pollution monitoring plan for the case study. That's all from me. Thank you.
For the last part, our group innovation for management of forest fire, we use the concept of integrated forest fire management, which is divided into 4 parts. The first part, prevention. We can do this by reducing ignition costs. This is also the most important part because it is the most cost effective and it can reduce greenhouse gases produced by fire. And then we can do this by banning the smoking cigarettes near forest areas and also minimize the use of fire. The next part, preparedness, we can do this by organizing and training the right people. So for mitigation, we can also install air monitor device and sensors and also a smoke alarm for detecting the smallest fire in forests. The next part, response, we can do this with water mist suppression. Water mist suppression
is like a water sprinkler, but it creates much smaller droplets so that it would spread wider and it is more water efficient. The last part, recovery, we can do this by rehabilitation. We replant the forest so that it can grow back into a healthy forest, and also build shelter houses around forest areas so that people living near there can breathe healthy air, because smog from forest fire contains carcinogens and can be dangerous for human health. Thank you for listening to our presentation. This is from Group 4